Hi Salesforce Hubs, my name is Shruthi MN and welcome back to my channel, CodeForce Chronicles. In today's video, we are going to understand an important concept, mastering flows. We will learn how flows work, what user flows, process workflows, and system data flows are, how we can optimize workflows, and how we can measure their performance. So let's get started. Fundamentals of flows. Let's start with the fundamentals of flows. A flow can be understood as a sequence of steps that takes an input, applies certain logic or decisions, and produces an outcome. There are three important things to understand here: inputs, decision nodes, and throughput. Inputs are the information that starts or enters a process. Decision nodes determine what should happen next based on specific conditions. And throughput refers to how efficiently the process moves from the beginning to the desired outcome. Understanding these fundamentals helps us design better and more efficient workflows. Pillars of workflow, of flow architecture. Now let's look at the three major pillars of flow architecture. The first one is user flows. User flows describe the journey a user takes through a digital interface. The objective is to reduce friction and make the user's experience simple and intuitive. The second is process workflows. These define operational sequences and hands-off between teams. They help ensure that tasks are completed properly and according to the organizational SLAs. And the third is system data flows. These focus on how data moves between backend systems, APIs, integrations, and different technology environments. So, in simple terms, user flow is about the user's journey. Process workflow is about how work gets completed. System data flow is about how data moves between systems. Anatomy of an efficient flow. Now, let's understand the anatomy of an efficient flow. An efficient flow should have structured logic and clear hands offs. Every efficient flow should begin with a clear, defined trigger. After the trigger, we have decision logic that determines what should happen next. For example, based on a condition, the process might follow one path or another. Another important concept here is the state transition. State transitions help us move smoothly from one stage of a process to another, whether the next step is handled by an automated service or a human. The key idea is simple. A good flow should reduce ambiguity and clearly define what happens at every stage. User flows versus system flows. Now let's compare user flows and system flows. First, we have front-end experience flows. These focus on user's experience. Things like user intent, visual clarity, cognitive load, and intuitive interaction. The goal is to make the experience as frictionless as possible. On the other hand, we have backend logic flows. These focus more on technical execution, data validation, concurrency, fault tolerance, and system latency. The goal is reliable and deterministic execution. So remember, front-end flows focus on the user experience while back-end flows focus on system execution and data processing. Flow optimization strategy. Now move now we move into the second major section, flow optimization strategy. Creating a flow is not enough. We also need to continuously look for opportunities to improve that flow. Flow optimization means identity, identifying bottlenecks, removing unnecessary steps, reducing delays, and improving throughput. The objective is to make the entire process faster, simpler, and more efficient. This is especially important when workflows become complex or involve multiple teams and systems. Frictionless flow principles. Let's look at four important principles for creating frictionless flows. The first is minimize decision fatigue. This means reducing unnecessary decision branches and automating simple routing decisions wherever possible. The second is eliminate latency hotspots. We should identify places where a process is waiting unnecessarily and reduce those delays. The third is implement fail safe loops. If an input is missing or something goes wrong, the flow should have a fallback mechanism instead of completely failing. And the fourth is continuous observability. 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 Sorry, there's a network issue. And the fourth is continuous observability. We should continuously monitor what is happening at different stages of the flow so that we can identify problems early. So the four principles are minimize decisions, reduce delays, handle failure safely, and continuously monitor performance. Workflow efficiency impact. The slide talks about workflow efficiency impact. The presentation highlights a 68% cycle time reduction as an example of the potential impact of restructuring legacy workflows into automated trigger action flows. The important concept here is not just the percentage. The key takeaway is that when we replace inefficient manual or legacy processes with well-designed automated workflows, organizations can potentially reduce turnaround time and improve compliance accuracy. So when we are designing a flow, always ask, can this step be automated? Can this handoff be simplified? Can this waiting time be reduced? Flow diagnostics and metrics. Now let's talk about measuring flow performance. There are three important metrics shown here. The first is completion rate. This tells us how many users or processes successfully complete each step and helps us identify friction points. The second is node dwell time. This measures how much time a process spends at a particular stage. If one stage takes significantly longer than others, that could indicate a bottleneck. And the third is error frequency. This tells us how often automated exceptions or errors occur. By tracking these metrics, we can understand where our flow is working well and where improvements are needed. Workflow through metrics. Now let's look at the categories of workflow tools. The first category is workflow filters. These focus on interface journeys and can support wireframing, clickable prototypes, and heat maps. The second category is BPMN platforms. These are focused on enterprise processes, formal process notation, audit logs, and SLA tracking. The third category is integration engines. These focus on data flows and APIs, including webhooks, transformation logic, and event queues. Event queues. And finally, we have no code automation. These tools focus on task automation using things like application connectors, conditional triggers, and email alerts. The important point is that different workflow tools solve different problems. Implementation timeline. Now let's see how we can implement flow optimization step by step. There are four stages. Audit. First, understand and document the current state flow. We also need to establish baseline metrics. Stage 2, re-engine. Next, remove redundant steps and simplify decision branching. Step 3, or stage 3, automate. Then we introduce trigger-based automation and system or API handoffs where appropriate. Stage 4, monitor. Finally, we continuously track performance and make improvements. So the complete journey is audit, re-engineer, automate, monitor. This creates a continuous improvement cycle. Question and answers. And now we have reached the question and answer section. This is where we can discuss how flow optimization can be applied to the real world user journeys and operational processes. If you're learning Salesforce Flow, this is also a good point to think about an automation scenarios. If your own automation scenarios, you can send your queries to shrutinarsi@gmail.com and not this email address. This is just an email address which I've created, but this is not. Uh, I can't. I'm not just. This email is suspended, so I want you to send your queries at shrutinarsi@gmail.com. If you're learning Salesforce Flow, this is also a good point to think about your own automation scenarios. For example, what starts the process, what conditions should be checked, what action should happen next, and what should happen if something goes wrong. These questions help us design flows logically. So that's a complete overview of mastering flows. Today, we covered fundamentals of flows, user flows, process workflows, system data flows, efficient flow architecture, user flows versus system flows, flow optimization, frictionless flow principles, workflow efficiency, flow metrics, workflow tools, and finally the implementation approach. The biggest takeaway is that a good flow is not simply about automation, it's about designing a process that is clear, efficient, reliable, measurable, and easy to improve. If you found this video useful, please like this video, subscribe to CodeForce Chronicles, and share it with another Salesforce learners. With other Salesforce learners. If you have any question about Salesforce Flow or workflow automation, leave them in the comments. Thank you for watching Salesforce Hubs. I'm Shruthi and I'll see you in the next video. Happy learning.